Hello fellow Kerbonauts, welcome to episode 4 of Kerbal Space Program Fully Loaded. And this is of course the Luna 1, the spacecraft that we sent towards the moon in our last episode. And it has a slight problem. It starts rotating as soon as we leave it alone and as soon as we use time acceleration. And I was suspecting the mod persistent rotation, which we use to rotate it always to the same location, pointing towards the sun. No, that wasn't the problem. The problem was in the SAS system that will get an overhaul with version 1.2 of Kerbal Space Program. However, I could fix it here by deactivating torque in the reaction wheel. However, this of course made the vessel almost impossible to steer properly for any action, so we kinda deactivate it every time we use time acceleration and then switch it back on once we need it again. So now we're going towards the moon, and this mission is, as its namesake might tell you, modeled after the lunar missions, of course, of the Soviet Union, which were, unsurprisingly at this point, if you look at the history of the American space program, the Russians were actually far ahead at the beginning of the space program, including sending stuff out to other celestial bodies, including the moon. And Luna 1 was meant to be the first lunar impactor. And due to a calculation error, it kinda missed the moon by 6,000 kilometers. However, Luna 2 then achieved this goal of impacting. So for this, I was kinda expecting sort of a flyby to fulfill the requirement for the moon probe or explore the moon mission that we accepted, and this is a goal that we have now already achieved. We just sent science from a flyby around the moon, and now we are going to try to circularize our orbit around the moon. Of course, we are going to burn retrograde at the periapsis, which sits about 25 kilometers here, and burn coming up 28 kilometers, 27. Of course, we are burning only as far as we need to kind of achieve a stable orbit, and you can see now that we have achieved a stable orbit, the notification window on top right shows an increase of a number, so we gained some goal here. You see it, we have a world first, the first orbit around the moon, which gets us a ton of cash and of course a contract complete as well. So now we are in an orbit around the moon, but it's a bit off, so we kind of start to burn radial, so we're kind of doing a loop-de-loop here, and at the right moment we are going to burn outwards from the moon, which does one thing: it pushes the point where we are at up, and this has to come from somewhere. So on the other side of the orbit, the point closest to the moon gets moved a bit closer, and this we use to circularize it to roughly 25 kilometers on each side. So apoapsis and periapsis are about the same. So, and this is already achieving more than I was looking for with this probe. I was looking for a flyby, which would kind of be what Luna 1 did for the Soviets. And now we are passing over to the dark side of the moon, which coincidentally is not necessarily always the case, of course. The moon is tidally locked in a way that with Earth, that we only see the side that always points to us. It's always the same, and the other side is always pointing away from us. But of course, the other side still is illuminated from time to time. This is why we actually have a gaining and a losing moon. So now we're coming out on the opposite side of the moon, and we are now not only back into the sunlight, but we are also having a re-established connection to the probe. And the question is, now that we have achieved all these goals, what to do. We still have a ton of delta V left, so the obvious choice is to go for let's try to call it an experimental landing, in the same vein as SpaceX likes to label their drone ship landings experimental landings, because it's not, part of the mission profile. Mission profile is getting the satellite into orbit, and then the mission is a success, and this is basically the cherry on top. And we are going essentially for the cherry on top, and the cherry being our spacecraft on the surface of the moon. And of course, this requires us to fiddle around with the reaction wheels once again. We did a deorbit burn already and are now on our descent, and I've picked a place that looked like it was almost flat. Of course, when the Apollo 11 actually landed on the moon, they chose a time where they could actually see the shadows of any rocks. And this is not the scenario we have here. We're kind of coming down around noon of moon time, so it's a noon. Anyway, you choose. And of course, you can see the altimeter telling us it's 2,700 something meters, when of course it is a lot less, which you can see to the right hand side of the altimeter, because we do have the actual radar altimetry that is only available in IVA mode, and this is added through the Flight Engineer mod, which is very nice. So we are of course trying to burn retrograde to have the rocket point towards or away from where the velocity is pushing us, or the gravity is pulling us towards the moon, and thus nulling out the velocity. And as you can see, we're kind of already seeing our shadows here, and we are already slow. There's no concern about fuel. We do have a ton of fuel left, or several tons, many hundreds of delta V. And of course, we are now close to touching down. It's 4 meters per second. And now we're almost close to turning around the prograde and retrograde markers, and now setting down at roughly 5 meters per second. And this is almost always misleading, because 5 meters per second doesn't sound so bad. But if you express it in a different way, like for instance 20 kilometers per hour, or maybe what's that in miles, maybe 15 miles per hour, it sounds like a lot more, or it's a more comparable everyday measure of velocity. So 5 meters per second isn't that slow if you imagine it. It's quite astonishing that the Kerbal Space Program engines do not take any damage, but this is of course a deliberate choice to make the game more accessible, to set the bar for success a bit lower for your everyday player. And still, there are lots of people struggling with the first orbits, etc., etc. So it's debatable, of course, how the optimal difficulty setting should be. And of course, we have kind of hit the jackpot here, because we are getting tons of science, tons of reputation, and tons of credits for so many world firsts and so many things that we have now completed with this remarkable experimental landing. Because we have not just completed the world firsts of landing on the moon, orbiting the moon and flying by the moon and sending science, we've also completed the contract Explore the Moon, which required us to get into orbit, send science from orbit, and land and send science from any biome on the planet. So question is what to do now. We still have enough delta V left to actually go back to Kerbin, but there's no way to bring the spacecraft down safely, and we might even be able to do something else here. So we're kind of investing our delta V to try for a second biome, to find a second biome, and maybe even, if the fuel holds, maybe even find a third biome. Because, of course, we have the moon probe strategy, and this strategy requires us to land on the moon and send science back to Earth from 3 different biomes. So the question is, of course, where are these biomes? We didn't expect to be able to land with this probe, so we didn't do any research on biomes, so we know next to nothing about the moon. And the question is, of course, where to look for a suitable landing place. And you see me here going back and forth between the map screen, trying to find this good spot to land, trying to find out where actually we might want to come down. And this is more of a looking on a map and saying, well, this area looks quite a bit different from other areas. Maybe this is its own biome. And I imagine that at some point some geologists must have done the same when they were thinking about places to land on the moon. Of course, those places were typically scattered, so landing places were typically suggested along the equatorial plane for obvious reasons. And here we kind of go for a different route. Of course, we are now flying over a ridge that seems like it could be its own biome because it has different colors, but we are trying to go a bit more closer to this lighter area for further north. We do have enough delta V left for this, and we might be able to touch down near the rim of the crater that borders on this lighter shaded area right there. And there you can see a total list of all the biomes that are available on the moon, which is quite a lot. So I'm cautiously optimistic to actually find 2 more biomes to touch down as long as the craft stays intact and we have enough delta V left. And of course you can see me here toggling torque again, because we need that torque to actually turn the craft sufficiently. And you can see that electric charge is kind of getting lower here because we cannot always rotate the solar panels in the right direction for them to charge sufficiently and to fill up our reserve. So here the question is, do we try to come down just before that kind of a hollow place, more on the hill, or maybe we go for the hollow? And I was kind of touch and go here and not thinking clearly, so we almost came down on this steep slope, but instead we kind of passed over it right here, and there is now more of a plane under us which we can use to try to touch down. And you see me here adjusting to make sure that we clearly are over this plane. We still have enough delta V left. There's no problem here, and we might, from the stats, it might even be sufficient to go for another hop to find a 3rd biome as long as it's close by. So here we try to angle the rocket to point towards the retrograde marker. And you can see there are still, it's quite slopey. I'm not even sure that that's a word. So us trying here to set down. Remember, this is not that slow. It might seem slow, but this vehicle is several tons and it's moving right now with speeds along, 20 to 30 kilometers per hour. So this is going to be a rough impact, which is coincidentally what Luna 2 had. Luna 2, then the Russian probe that first impacted the moon in '59. And then it took them 7 more years to actually soft land something on the moon, which was the Luna 9 probe, which touched down very, very gently compared to the lunar impactor, which had quite a lot of force behind it. And it did a soft landing just as we do here, with a speed of maybe 5 meters per second, and then sending back photographs. We are sending back thermometer data and actually magnetometer data. And if you look at the Luna 1, Luna 2 probes, they actually too had a magnetometer on board. I was actually surprising to see that they packed micrometeorite sensors Geiger counters, something for Cherenkov radiation, and sodium vapor experiment, tons of interesting stuff that you wouldn't have thought somebody would put on a probe basically aimed for smashing on the moon. But they did. They put a lot of instruments on there. And for Luna 1, it was actually not that bad that it missed the moon, since it is now the first object ever to enter into a heliocentric orbit, ever to leave the influence of Earth and passing by the moon at 6,000 kilometers distance. And it's now circling the sun somewhere between Earth and Mars. So it's still out there, along with two sort of balls of emblems with the Soviet coat of arms on it. So it's interesting, and I wonder if everyone ever is going to do some space archaeology and try to pick up those crafts that are kind of lost. Anyway, we are not yet lost. We are trying to land in a third biome, which we do not know if it's really under us, but we kind of passed over this ridge into this more sort of a bit whiter area, and in the hope of it being a third biome, so that we can actually complete the moon probe. Yes, that's what's it called, the Strategy moon probe, and get our third science from a third biome here. And as you can see, I kind of miscalculated how far the ground is. I kind of looked at the classic altimeter and not at the radar altimetry that was to the right of it. And as you can see, we're kind of off our retrograde marker here, but now kind of the rocket bouncing off, of course, is really not what I was expecting. But still, the rocket is intact, and since we only have like 200 something delta V left, this rocket is not going anywhere, so it would have been okay if the actual engine would explode. But we kind of set the craft down gently and tilt it over so that the solar panels are oriented towards the sun, or at least away from the surface of the moon. And now we collect science, and it is indeed from another biome. And so we send out this science, completing our moon probe strategy in the first go with Luna 1, which was quite surprising to me. So now the question is what to do with this craft. We kind of leave it here, of course, and we will do the other experiment, the magnetometer, and we will maybe revisit this probe to use it as a sort of a relay, because it does have two antennas on it, even though the second antenna is not that suitable for long-range communication. So here it is, the magnetometer data, and now the mission of the tiny probe that could really is complete. And there's nothing more to do than to switch off its systems for the moment, allow it to recharge the batteries whenever the sun comes around, and, well, maybe revisit it at some later point, maybe with space archaeologists. Question is, of course, how much cash did we really obtain? How much is this mission really worth? And of course we need to look at the damage here. And you can see we are getting the contract complete for moon probes, which is not that much, but considering that we have completed 5 goals of this, so it kind of adds up. And of course we have activated To Boldly Go To, which is a strategy that gives us more science, more cash for science that we collect from other bodies, and more cash for science that we collect from the moon. And now we have actually almost 1.5 million credits, which is a lot. Really is a lot, considering how we started with like 15,000 funds. So, and of course many strategies are now available to us with this profound success, but of course moon probes is no longer available since we have completed it. And the question arises, of course, what to do with this unrivaled success, and of course we need to look at strategies. And what better day than today, one day after the 54th anniversary of the Texas speech by Kennedy that I referenced in the previous episode, than to accept the Apollo program strategy and to aim for the moon and to send the Kerbal to the moon before the decade is out and bring him back safely to Earth. And that's us for this episode. Thank you for watching and see you next time. Bye!